Okay, so problem 34 uses the generic model. For the generic model, you need to draw the picture, state the relevant equations, then state the relevant equations with their variables, then state the filled-in equation, and then solve. So, for problem 34, there are 3 girls jump roping with a rope that is 3.8 meters long. The speed of the rope is 95 meters per second. To find the fundamental frequency, we look at the first harmonic. In the first harmonic, the length is half of the wavelength. Because we know that the velocity is equal to the frequency divided by the wavelength, right here, we can derive the equation to solve for frequency. So for part A, we know that the fundamental frequency is equal to the velocity of the rope divided by 2 times the length of the rope. So 95 meters per second divided by 2 times 3.8 meters to get a frequency of 12.5 hertz. For the next higher resonant frequency, we know that the length is equal to 1 wavelength. So we derive the equation frequency is equal to velocity divided by length, or 95 meters per second divided by 3.8 meters to get a frequency of 25 hertz here. For part C, or the third harmonic, the length is equal to 3/2 of the wavelength. So based off of the frequency, we would use the equation 3/2 times velocity divided by the length, right here. So 3/2 times 95 meters per second divided by 3.8 meters to get a final frequency of 37.5 hertz.